Now, as we go through module 3 or chapter 3, however you want to think about it, it's a lot about using a function notation, some of the things that goes along with functions, okay? So let's go ahead and start this, and then once we've done this, we are going to open up the pre-course M33 that is due today. We're going to work through that together, okay? So first off, it says here that if A is the area of a square measured in square inches and S is the square's side length measured in inches, then the square's side length S and its area A are related with the formula A equals S squared. So let's just draw a square. You can probably draw it better than me. Let's put a little S on both sides, and let's put what they told us. Okay, so we know that the area is A. We know that S is in inches, so A would be square inches. Okay, so make sure you understand exactly what they told us, and then we are going to use the function g to rewrite it in function notation. So g of S is S squared, and that's what they say right here. Okay. Now you'll notice in A, see the words here, how they say to not calculate it. I've noticed even in the pre-course M33 we're going to do here in a minute, that they mention the fact don't calculate it, just kind of set it up, okay? So it says use function notation to represent but not calculate the areas of two different squares with side lengths 3.5 and 26.92. So if we talk about these areas, G of 3.5 represents the fact we're using the area formula, and the side length is 3.5, and then G of 26.92 would say we are calculating the area of a side that is 26.92, or square with side length 26.92. That's all they want to do, okay? Now B says, interpret the meaning of G 4.9 equals, or G of 4.9 equals 24.01. Can anybody share with me, what do you think that means? Yes, Gavin. You are correct. So that's our area in square inches. Yep. So if we put that into words or into context, we would say that if we have a square with side length 4.9 inches, so that would be inches, we would have an area of 24.01. So remember, that's the point, 4.9, 24.01. This is in inches. This is in square inches. Okay. So in C, it says, don't solve it yet, but let's explain what this means. If it says that G of S is equal to 81, and we wanted to solve for S, all that's saying is, if the area is 81 square inches, what side length would give us that? What side length? Let me put the word side length. So G of S equals 81 tells us that kind of we're going backwards. Yes. Now remember that they didn't ask us to solve it, but let me, yeah, but but let me show you. If they did ask us to solve it, you would want to take out the G of S portion, replace the formula there. So the formula is S squared. And so S would be the square root of 81. Now, this is one time we're putting up plus or minus. You can put it initially, but we only want the positive version because the negative version for a length is not something we write length as. So if we were to solve it, they didn't ask us to, you would get an answer of 9. And actually, in context, we would put 9 inches. So the side length would be 9 inches. Okay. Now, D says to actually solve for it, where G of S is S squared, where the area of the square is represented by G of S. So you can replace this G of S then with its formula, meaning that S would be the square root of 24.01. Again, I didn't include the plus or minus because for a side length, we don't need that. Now, I'm okay with you leaving it there. 24.01, I don't believe is a nice square root. So feel free to leave it there. It's a number a little bit under 5. Actually, it does come out pretty good. It's 4.9, and that would be inches. Okay. Now, E says to explain which of the following represents G of 5 plus 23, and then 4 times G of 3.4. So let's talk about just the meaning. We're not going to calculate it. They didn't ask us to calculate it. So this would be the area if our side is 5 plus 23. What does that mean in context of real life? I don't know. Maybe we want to find the area of a square with side length 5, and we know we need to add 23 more square inches. I don't know. Okay. In E2 there, 4 times G of 3.4, that would be 4 times the area when the side is 3.4 inches. What does that mean? What is that trying to tell us? I don't know. We could do that very simply. We'd do both of those. We could get numbers very simply. The first one would be 25 plus 23. The second one would be whatever 3.4 squared is times 4. So we can calculate those things pretty nicely, okay? But what they're trying to remind you of in this is that there is a context there. There is a number there. There is a meaning because they've given a meaning to the function. So that's all they're trying to get you to kind of see there. Okay. Now let's take a look at number 3. It says the amount of medication per dose of a specific medicine needed for a patient varies within the patient's weight. If G determines the number of ounces of medication in one dose in terms of the patient's weight, X in pounds, determine which each of the following represents. So over to the side, let's write down what they told us. They said G is the ounces of medication, and they said X is the weight of the patient in pounds. So you should always write that down, or you could highlight it. Highlight those important information, those context information clues. Those are always important that we know. So G of X is the, let's say that the person weighs X pounds, gets G of X ounces of medication. So that's what it would mean in words. Start with the inside, work your way to the outside. So X is on the inside. That represents a person's weight. So a person weighs X pounds, and they will get G of X ounces of medication. So X just represents the person's weight. G just represents the ounces of medication. So G of 145, says that if a person weighs 145 pounds, they get G of 145 ounces of medication. Now, they didn't give us an actual formula for G. So at this time, we don't have enough information to go further than that. We're just saying, okay, that represents, what does it represent? It means that a person of 145 pounds should get G of 145 ounces of med. What that is, I don't know. Until they give us a formula, we don't know that. So I want to jump, I don't care about those two as much as I want to talk about G and H. G and H are really important to distinguish which is which and how that it's worded, because of the fact that it's just telling us so much information. So if you look at G, a 195-pound person gets 2.5 ounces of medication. That tells us a lot of information. Yes, they didn't give us a formula for it, but they have calculated it for us. So that's super important. Now, what H is telling us is a little different. It says the solution to G of X equals 3.25 means that at what weight X should we give 3.25 ounces of medication? That's what that solution would tell us. What is the weight X that matches giving 3.25 ounces of medication? Well, we can't answer that right now. We don't have an actual formula. But think about how much information that tells us. A lot of good information, okay? Okay. So let's finish. Let's do 4, and then we're ready to start the pre-course together, okay? So it says the given table represents the retail price in dollars of a brand new Toyota Camry as a function of the number of years after 2000. So that would be N, okay? So remember, this is F of N. That's the price of the car in dollars. N is the number of years after 2000. So our input is our N. That would be the number of years since 2000. That is our independent variable. Our output is that price. So that's F of N, which is the price in dollars for the car. Remember, they gave it to us in dollars. So obviously the chart has organized things nicely. It's always a good idea to read over what the question is asking. What is our N? What is our F of N? What do they tell us? So B, F of 7 says, or B says to evaluate each of the following, describe the meaning of its context. Well, that just means at year number 7, what is the price of the car? Well, that's what the chart's going to tell us right here. At year 7, the price of the car is $19,995. So let's write that in words. So 7 years after 2000, so in 2007, the price of a Camry is $19,995. So in words, that's what that means. Now you could say 7 years after 2000, but we know what that means. That's 2007. The price is 1995. So this one means, well, the answer, first let's get the answer out of the chart. The answer is that 25,925. And what does that mean? Well, in 2020, the price is 25,925. So the price for the car is $25,925. Now, C is kind of interesting because what C does is it goes backwards. So this is saying what year or how many years after 2000. So how many years after 2000 would the price be 19,295? So when they say that f of n is 19,295, they have given us the dependent variable. We need to find the n, or the independent variable that goes with it. So just look for 19,295 up on the chart, and the answer would be 5. So 5 years after 2000, or in 2005, that's the price that we would expect to have for the Camry. Now, let's just do a few more just before we're ready. Let's finish out D here. It says, evaluate its expression and describe its meaning and context. So this is the change in price from year 2005 to year 2007. So because it's always ending minus beginning, our ending year is the 7, our beginning year is the 5. So in 2007, it was 1995. 19,995. Yeah, 19,995. In year 5, it was 19,295. Or it was a positive change. It went up by $700. So in the meaning of the context is, between years 2005 and 2007, the change in the price was $700. That's what that means. The second one, we already found f of 5 was 19,295. If you add on 1250, that's 20,545. So we've increased the price at 2005 by $1,250. That's what that would mean in words. And this was, how many times would the price in 2024 how many times would the price in 2010 go into the price in 2024? How many times bigger is the price in 2024 compared to the price in 2010? So that's 2835 if you look up on the chart. So if you divide those, let's go two decimal places. So we would say that the price in 2024 is 1.32 times larger than the price in 2010. That division tells me how many times it goes into it, so how many times larger. So that's our 3-3 investigation. So go ahead and turn that in, and then go into your iMath, and please, could you open up the pre-course M33, which is due today. So it should be on your calendar for today. So it looks something like that. They're talking about a candle. So if you could please open that up for me. Let's go ahead. Now remember, your numbers and my numbers are probably different, so change your numbers accordingly. You may want to have a calculator with you, so there's some on the back if you want to grab yourself a calculator. Let's go ahead and work on this together so that you'll be able to then have this done. So it says G is a function that represents the remaining height of a 21-inch candle as a function of the number of hours T. So let's write that down, that G of T is the remaining height of the candle, and it's going to be in inches. And then it says T is the number of hours, so let's put that down. So it's the hours that it's burned. So it says, in my case, my candle was 21 inches. My constant rate of change is 3.1 inches per hour. So I'm going to write down my function over here. Your function and my function, change your numbers accordingly. But it was 21 inches. And for every hour that it burns, it goes down by 3.1. Okay. So again, your function and my function might be slightly different. Maybe your candle's 20 inches, 19 inches. Maybe your rate of change is 3.1, 3.2, 3.4. Don't know. Please change yours accordingly. Okay, so it says in the first bullet there, I. It says the height of the candle when it is burning for 4.2 hours. We are only using function notation. We are not calculating it. Remember how that one problem said don't calculate? So in my case, that would just be G of 4.2. Now please look at what yours is. Yours might be G of 4.1, G of 4.7, G of 4.8. Okay, so that's all you need to type in at that spot. You are not doing the calculation. You are just using the function notation. Okay. Now, the second one here says, use function notation to represent the number of inches the candle burned during the time period from 2.1 hours to 4.6. Again, use yours accordingly. I am going to put G of 4.6 minus G of 2.1. Now again, your numbers and my numbers might not be the same. That's all I'm writing in there. Remember, it's always ending minus beginning. That's why the 4.6 minus the 2.1. Again, put yours accordingly. I don't know what yours is compared to mine. Now the next thing says, use function notation to represent the height of the candle is 15 inches. Again, yours might be different, but that is basically the function gave me an answer of 15. Again, yours might be 14, yours might be 13, I don't know. But your function gave me an answer of 15. The height remaining is 15. Okay. And then bullet 4 here. How many times as long as the candle when it was burning for 2 hours as when it was burning for 4 hours? So again, how many times? We had done one like that before. So I'm going to put there how many times. So I'm going to do G of 2 divided by G of 4. I don't know what your numbers are compared to mine, but I think that's going to get us what we want for that one. And then finally, in this last bullet here, it says the height of the candle measured in feet instead of inches. Well, we know, look at what we've got up here. The height of the candle is G of T in inches. What is the conversion? How many inches does it take to make a foot? 12. So we're just going to use that fact, and we're going to write that as G of T. Our inches, just divide that by 12, and we'll convert it to feet. So I believe that's what they want for that first section. Does anybody have any questions about what yours is saying? Again, account for the fact your numbers and my numbers aren't the same. Is that good? Okay. Now in B, it says, write an algebraic expression that represents how each value of the independent quantity corresponds with the dependent quantity's value. So they just want the formula, but not the whole formula. They just want the expression part. So remember what I wrote right here? They just want this portion. Now, please make sure you're accounting for the fact your numbers and my numbers might not be the same. So for me, I'm going to write down 21.31t. Yours might be 21 minus 3.2 t. Yours might be 19 minus 3.1 t. I don't know. Please account for the fact that yours and mine are different. Now here I really want to talk about interval notation and how it reflects the domain and range. Okay, let's first talk about the range, because for this one, it's kind of interesting. Normally range is a little more different to think. But if we talk about the height of the candle, my candle started at 21. That was the highest it could go. The lowest it could go is to 0 when it's all burnt out. So mine goes from 0 to 21. You always follow number line order. Even though it's decreasing, it's going from 21 to 0. You still follow number line order. So the lowest, mine could be a 0, my highest is 21. Count for yours might be different than mine. Yours might be 19 or 20. Yes.
Getting a quick reminder, when it's the brackets, that means like that is as far as it can go.
Very good a reminder that those brackets are telling us that those are viable heights. It will get to 0 if it's all burnt out. It will start at 21. Yes, exactly. So use that bracket, please. Now, domain is a little harder to think about. Domain are the times. Remember, T is time. How many hours is it going to take? So for you and me, we might be a different thing. But let's take this formula, whatever you typed in, and if you set it equal to 0, and we solve for t, that will tell me how many hours it takes for my my height to hit 0. So if we do 21, in my case, 21 divided by 3.1, I got 6.7742. Now, you might get something totally different. I don't know what you got, but mine will be from 0 to 6.7742, both again in brackets. Because at time 0, I'm still at 21 inches on my candle height. At time 6.7742, my height has hit 0. So that's where the function equals 0. That's technically our x-intercept, or our horizontal intercept. So yours and mine might be slightly different, but so calculate those. You'll probably have to do a little math to figure out what those are. And then finally, our last thing here says use function notation to represent the rate of change of the candle's height with respect to time as the amount of time since the candle started burning increases from 1.6 to 5.6. So the rate of change of the height, remember it's ending minus beginning. Now yours and mine might be slightly different. So this would be, for mine, it would be 5.6 minus 1.6. So then you have to divide, I got negative 12.4 by 4. So I get negative 3.1. So you're going to get roughly a number somewhere around negative 3. It's a constant rate of change. So if yours was 3.2, you should get 3.2 in this spot. See how mine was 3.1? So I got 3.1. Thank you. And because the reason it's negative is because it's burning down, and that subtraction, that negative on there. So that's a wonderful observation, which of course I should have mentioned to you. This rate of change is your slope. So you should get that slope if you've done it correctly. Okay. So this should be done then for you, hopefully. And then we will, you'll have a few minutes now to start looking at some of the homeworks. Remember, if you're not getting this stuff done, please, 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 you're not spending enough time through the week. Don't just wait until the due date to get started. Okay? So there you go.